So hello everyone, welcome back to Chemistry is Easier for You. As some of you have requested, we are going to do Delhi University MSc Chemistry entrance previous paper today. As QCET papers helped you, I hope this DU MSc Chemistry entrance previous paper discussion also would benefit you a lot. So I have already written the first answer. We are going to discuss it now. So the first question is the compressibility factor for an ideal gas. So what is compressibility factor? Compressibility factor is Z and is denoted as and the value of Z is PV by nRT. For an ideal gas, PV is equal to nRT, and for this condition to be possible, we need the value of Z as 1. And we have also written Z is equal to 1 for an ideal gas in the all formula discussion of gaseous state. We already discussed this part, but I was just telling you how that value is coming. You already know that it is equal to 1, but how does this come? Because Z is equal to PV by nRT, and for an ideal gas, PV is equal to nRT. So for this condition to be satisfied, Z will be equal to 1. Now we will go to the second question. So the second question here is the IUPAC name of the following compound. We have to do the EZ nomenclature here, because we do not need to find the name here because name is common for everything. It is 3-chloro-hexa 2,4-diene-1,6-diol itself. Only thing that we have to do is here at the second carbon and the fourth carbon, the double bond is there. What notation? Either Z or E notation. Which one should we do? That is the thing that we need to find here. Now the way to do this is, if you mark it in here itself, you will get confused because we are having two double bonds and you will get confused. So we can write it separately, find the EZ nomenclature of both the double bonds separately. I will write this one first. So how to write it? Here we are having the double bond, and this carbon we are having a chlorine. Then this step we will be just marking as carbon because all the other are carbon R group only. Then here also it is the R group, the carbon group, and we will be having hydrogen here. Here hydrogen is not marked, but we have a hydrogen here. Now we will start numbering. We will give the priority. Here this R group is carbon, and definitely that is having the higher atomic number, and therefore it will be having the priority 1, and hydrogen obviously will be having the priority 2. Now out of chlorine and R, here is carbon chain. So out of carbon and chlorine itself will be having the first priority, and carbon will be having the second priority. Now if the higher priority group are on the same side, then what will be the nomenclature, or what will be the notation? It will be Z. So it will be 2Z. Then out of option A and B, out of option A, B, C, D, C and D will not be our answer. Why? Because in C and D we have 2E, but our answer should be 2Z. Now we will go to the second double bond. The second double bond also we will be writing in a similar way. Here we are having the R, and so definitely here we will be having hydrogen. That is, here it is not marked, but we have a hydrogen here and here. And also there is an R group here and a hydrogen here. Now giving the priority, carbon will be having the first priority, hydrogen will be having the second. Again carbon will be having the first priority and hydrogen will be having the second. Now the higher priority group are on the opposite side, and therefore the notation is E. So our answer is option A, 2Z, 4E, 3-chloro-hex-2,4-diene-1,6-diol. Other options we need not consider at all. So this is the way, when more than one double bond is present, we have to separately write down the double bonds, find their notation, and then do that. If you are very confident, you can do it in the same chain itself, but better to write down separately and do to avoid confusion. Now I'll go to the next question. So the third question here is, what is the principal product of the following reaction? We are having anisole, then excess hydrogen iodide, and also we are doing heating. Now let's see what the product would be. We will check the mechanism as well. So anisole can be written as, anisole will be like this, OCH3, and there are lone pairs of electrons on oxygen, and we are giving HI. HI can be written as H plus and I minus. This hydrogen will be abstracted by the lone pair on oxygen, and as a result we will be having the Now we will be getting the product OH, and there will be a positive sign on oxygen because the lone pair is used to abstract proton, and again it will be having the lone pair will be there. So yes, now it is having the oxygen. Since it used one of its lone pair, it will be having a positive and the other lone pair will be existing as such. Now here we are having an I minus. The I minus is not used yet. Now this CH3 will be giving its electrons to the oxygen so that the positive charge will be now gone, and this CH3 will be leaving as CH3 plus. So what will happen in the next step? In the next step, it will become OH here, and the CH3 plus and the I minus will together form CH3I, and therefore our answer will be option B. The anisole in excess HI and reflux, the product will be phenol and also CH3I, MEI. So now we'll go to the next question. The next question is related to the topic of aromaticity. So what is the rule of aromaticity? Huckel's rule of aromaticity says that Huckel's rules of aromaticity states that a planar, cyclic, conjugated system with 4n plus 2 pi electrons are aromatic. So this is Huckel's rule of aromaticity, and the n can be equal to 0, 1, 2, etc. And also what is now how it will become anti-aromatic? Anti-aromatic will be having the similar condition except for the fact that it will not be having 4n plus 2 pi electron, but instead it will be having 4n pi electron, and n will be equal to 1, 2, etc. There won't be 0. Now how to check each of this? Let's see. Here there are 2, 4, 6. 6 pi electrons are there, but this is not planar. Why? Because all these are sp2 hybridized carbon, but here we are having one sp3 hybridized carbon. This is sp3 and all the others are sp2 hybridized. So this is not planar and therefore one is not aromatic. Now let's consider the second one. Here everything are aromatic, sp2 hybridized. So it is planar and we are having conjugated. Here one double bond, then conjugated, and after one single bond we are having a negative charge. So it is conjugated also, and now we have to check the number of electrons. Here 2 and 4. We are having 4 pi electrons, and therefore this becomes anti-aromatic and not aromatic. Anti-aromatic. Okay. So that is also not our answer. Now we will see the third one. Here also it is planar and it is conjugated and it is cyclic also, but here also we are having 4 pi electrons. So we will be having anti-aromaticity here. So definitely our answer would be option 4. Now let's check how it is. Here we are having 2 pi electrons. 2 pi electrons means 4 into 0 plus 2 pi electrons. That is, this is satisfied. 4 and plus 2 pi electrons is satisfied. And this is conjugated and planar. And therefore this is aromatic. And that itself is our answer. Now we will go to the next question. This is a very simple problem from the part of electrochemistry. So what is given here? We need to find the specific resistance or resistivity. The area and the length is given along with the resistance. So the formula that we need to use here is resistance R is equal to rho. Rho is the resistivity. Resistivity into L by A, where L is the length and A is the area. Now how to write rho now here? Rho will be RA by L. Now let's substitute all the values. The resistance here is 8 ohms. The area here is 4 and the length is 2. So what will be the answer? It will be equal to 16. Now why do we know? We did not change the centimeter. Why? Because our answer is also in centimeter itself. So our answer will be option B, 16. First of all, what you have to do in all these kinds of question is you should check whether you need to change the unit. Because if the answer is given in the same unit as the question, please don't change it and make it into SI unit. Don't do that, because if you do that, it will be simply making your answer mistake. For confusing you, they will definitely put such questions. I remember in JAM 2016, one of the question was asked to find the activation energy, and they were asking to find it in kilojoules. They specified it in the end of the question, but all of us simply found the answer in terms of joules, and we, that was in the numerical part, and we simply wrote the answer in joules, but they clearly specified to find it in kilojoules. So read the question carefully and what unit you need, and if options are given, read the options as well, and the units should match in the options and also what we are substituting in our formula. So do that very clearly. Try to do that. Now we'll go to the next question. The halogen having metallic character is. The problem with these kinds of question is, you most of the times you will not have any reasoning why this happens, or why do we have metallic character for this particular element. But in those cases, remember these kinds of question and the answers. That is, you cannot remember it by some connections or logics, but simply remember the answer as such. So here our answer is iodine, and you should remember that out of the halogens, iodine and astatine also are astatine, these will be having the slightly metallic character, and therefore you should remember these, and according to your option, please write down the answer very carefully. In P block and S block, the only way to score maximum mark is to do as many questions as possible and remember the answers of all such questions, because anything can be asked from S block and P block. It is not a restricted area, or you do not have a limited number of equations to learn. You have a lot of facts to learn. So in those cases, listen carefully that you have to do as many questions as possible and remember all the answers. Now the next question, cobalt is present in. This can be considered as a question from the biomolecules part, and the answer is vitamin B12. This question was also asked in Pondicherry exam and also in Central University Common Entrance Test. So this is very important. Vitamin B12 contains cobalt, and also chlorophyll has magnesium. This is very important. This part is even important for NEET students. If you are watching this, please note down this, that these two things are important for you as well. When you reach in the MSc, the postgraduate level, then you will have more number of biomolecules to study, but now you are having a limited number of biomolecules, and to try to study those thoroughly, cobalt containing biomolecule is the vitamin B12. There will be many other, but what you have to remember is vitamin B12, and chlorophyll contains magnesium. So that is one important thing. Now we will go to a problem, the numerical problem. So the question here is, the partial pressure of carbon dioxide in a mixture of carbon dioxide and N2 is given. Then, and also the total pressure is given. Now we need to find the mole fraction of nitrogen in the mixture. So let's remember what all equations can be substituted here. So I have already written the answer here. Now we will be discussing that. P total is equal to partial pressure of carbon dioxide plus partial pressure of nitrogen. This is from Dalton's law of partial pressure. So according to Dalton's law of partial pressure, in a mixture, we can write the total pressure in the terms of partial pressures of the gases which are present in the mixture. So from this, we already know the partial pressure of carbon dioxide as 1, and P total is also given. Now first of all, we will be finding the partial pressure of nitrogen. The partial pressure of nitrogen will be 4 atm. Now another relation that we have studied is that the partial pressure is equal to total pressure into mole fraction. Now how to find the mole fraction? Mole fraction will be partial pressure divided by total pressure, which is equal to 4 by 5, and the answer would be 0.8, which is option B. So that is our answer. Now very important thing is that in this part, in that gaseous state, in this part, very importantly, you have to study all the fundamental laws like Boyle's law, Charles' law, ideal gas law, and Dalton's law of partial pressure. All this you definitely have to study, because without studying this, you cannot attend the question of any PG entrances, because in case of PG entrances, question comes from all the parts. Every part at least one question comes. So without learning these kinds of basic equation, don't go to your examination hall. Especially in Delhi University MSc paper, the trend is that we will be having very less number of complicated questions, but we are having a lot of questions that test your basic knowledge. So just study the basic facts first and then go to complex questions and complex question practice. So that is my advice to you. Please try to follow that. Now we'll go to the the next question of the day. Here is the covalent radius of lithium is given, and what is the crystal radius is the question. So what you have to remember is that crystal radius is always less than the covalent radius. I have indicated covalent radius as CR. So crystal radius is always less than covalent radius. So what will be our answer? Our answer will be less than 123. This is a fact, and just learn that. Just remember, whenever questions from this part comes, just remember that we have already seen a question like that. So the radius of crystal radius will be always less than the covalent radius. Now the final question is from one of the topic that I have recently taken, that is photochemistry. Photochemistry, here it is match the following type of question, and we can see, I will just zoom out so that you can see all the options together. So what are the questions here? First of all, phosphorescence is given, then intersystem crossing is given, Jablonski diagram is given, and fluorescence is given. Then we can just go through the options. So these are options. In most of the times you will be getting confused with these kinds of questions. So what is the trick in these kinds of match the following question? I will be telling you that. You will get confused with this phosphorus, fluorescence and intersystem crossing. But one answer that you are very sure of is the Jablonski diagram, because it is the only answer which matches the schematic representation of various type of radiative and non-radiative transition. So you know that C is the correct match for the one in this side. So C equal to 1. Okay, C matches with 1. Now let's go through the options here. So if you go through the options, luckily you can see that there is only one option, that is option A, where C is matched with 1. So definitely that itself will be our answer. So this is the trick in the match the following question. It may not work. It may work in 99% of the time. Only in 1% of the time this will not work. So what is the trick here? Just look through the options for the one which you are completely sure of. Like here, Jablonski diagram, that is C is a match for 1, that you know. And now when you go through the options, you know that only one option is having C matched with 1. So definitely that itself will be the answer. Now we can go through the options once again. Here A is given as 4. Let's see. A is phosphorescent. And what is 4? Spontaneous emission of radiation between energy states of different multiplicities. It is true, because T1 to S0 is the phosphorescent. So that is from different multiplicity, T1 to S0. So definitely that is correct. Now next, what it is? B is equal to 3. What is B? B is intersystem crossing, and 3 is non-radiative transition. We know that intersystem crossing and internal conversions both are non-radiative transition. So that is also right. That is also right. B matches with 3. Now we have only fluorescence and option 2. Fluorescence is spontaneous emission of radiation between energy states of same multiplicity. It is true, because it is from S1 to S0. This here non-radiative transition between, this will be S1 to T1. So these are correct. So I have already said in photochemistry a limited number of questions come, out of which one will be the Jablonski diagram. If you have not watched the video yet, please do watch the photochemistry video, because it is very important, but it is very simple as well. Very easily you can score the mark if a question comes from the photochemistry part. So we will be continuing the quiz at Pondicherry University BHU, and also now the Delhi University previous year papers. Will be continuing that for the PG entrances till your exams. If you have any other doubt, please do ask in the comment section below. We'll be doing whatever videos you ask us to do. We'll definitely try to do that for you as quickly as possible, because we want you to score the best and have admission in a very, very good institution. So all the best. Study very well. I hope you get the highest of the ranks. Thank you. Keep watching. Subscribe our channel and hit the bell icon for latest notification. Thank you, students. Thank you.